Welcome back to Nunley Math. I'm Aaron Nunley, your host, and I'm very excited to have you here with us. Thank you so much for joining us today. We are working our way gradually through our unit on solving equations. We've talked about a lot of equations and a lot of properties. We're going to refresh those very quickly and try and make our last expansion on those here today so that you can solve increasingly complex and challenging problems. Now we're going to do this this first part fairly quickly because I think a lot of this should be reviewed for you at this point, but it's always good to have things fresh in our memory when we begin our new section. So without further ado, here we go. The one big idea that I keep mentioning over and over again is that all of algebra is based on the idea that there are certain patterns that exist in number, and that these patterns are regular, they are predictable, and they are unchanging, and that we can apply these same rules in creative ways to solve increasingly complex problems. And you can see over here on the right, I've got a algebraic properties of real numbers chart that I find to be very useful. In fact, I would suggest that you use your snipping tool and grab a snippet of that chart and print it out for your own reference throughout your study of algebra, because those things do get used over and over again. And then you can see that down here in the bottom I have one of the very simplest equations that we solved way back in the first video or two. Notice the original equation says x plus 5 equals 7. We use the property of equality to subtract 5 from both sides because we knew that 5 minus 5 would give us a 0, and the identity property tells us that adding 0 does not do anything. That was where we started. Then we began to grow into increasingly complex problems. And as we did that, we talked about being able to justify the changes we made by mentioning these properties as we go. And so what I would do is I would give you an equation kind of like this, and then as we solved it, we would use properties to justify any changes. So what I'm going to do here is I'm going to show you step by step how I would solve this problem. And remember, this isn't the only way to do it, but it is a very useful and helpful way to do it. And then what I'd like you to do is between each change, I'd like you to pause the video and think about the property of the justification, and then I will tell you the justification and you can check yourself, and once you've done that, then move on and so forth through the problem. Here's the first change that I would make. There's our original given problem. This is the first change I would make. Go ahead and pause the video, see if you can figure out what property allows you to make that change. Hopefully by now you realize that all I've done is changed all these subtraction signs into adding the opposite, adding the opposite, adding the opposite, and hopefully you realize that that is the definition of subtraction. Try this one. In this step, I've taken the -3 and distributed it to both the 2x and to the 5. That is known as the distributive property. How about here? Notice in this case, the only thing I've really done is moved this -5x over to here and moved the 2x after it. Remember, since this is one long string of addition, it doesn't matter what order I do things in, so I can rearrange that addition any way I want. That is the commutative property. How about that? In this case, I've added parentheses into the problem, both here and here, to group my x's together, to group my numbers together, and of course that is the associative property. How about this one? I took all my x's and combined those. Combining your x's, a lot of people call that combining like terms. The technical term for that is the distributive property. And then the next step, hopefully you realize, is just simple computation. If you were to say addition, that would be correct as well. At this point, I'm in my familiar two-step equation format, and hopefully by this point in time you realize that we're just going to use the property of equality, computation, identity to get rid of the -30, property of equality, computation, and identity to get rid of the -5. Notice once again that equality, computation, identity pattern, which comes up over and over again. How'd you do? I'm sure you did a great job. here's what I want to do today. I want to take this equation over here. I want you to stop and think about how this is different from the ones we've seen before. Take a moment and think about that. In this equation, we not only have an x on one side of the equal sign, but we have an x on the other. We have variables or unknown values on both sides of the equal sign. Fortunately, the property of equality can still be used here because it says I can do whatever I want as long as I do it on both sides, or whatever I do on one side, I can do on the other as well. Remember, the purpose of the property of equality is to change the appearance of the equation without changing the solution. So we have a lot of different options for what we can do here. I could subtract 9 from both sides. That would be the property of equality. I could subtract the 9, no problem whatsoever. I could add 47. Notice that subtracting the 9 gave me a 0 on the left, which the identity property would get rid of, but adding 47 gives me a 0 on the right, which the property of equality, or the identity property, would allow me to get rid of. But those are not my only two options. The property of equality says I can do anything I want as long as I do it on both sides. So I could use the property of equality to move my variables as well. Remember, the variables are just numbers we don't know yet. I don't know the value of 6x, but whatever it is, if I were to subtract it from both sides, the property of equality says that would be fine. So in this particular problem, if I wanted, I could subtract 14x's, because 14x's take away 14x's would leave me with a 0, and the identity property says 0 plus 9, the 0 would go away. Or I could subtract 6 from both sides. The property of equality says that would be fine, as long as I do it on both sides, since 6x is some number, and minus 6x is that same number. When I subtract those, I would be left with no x's. Notice, by the way, this is the one that I'm choosing to do. I could have done any of these, but I like this one better. Notice that 0x, 0 times anything is 0, and of course the identity says if I add those together it would not be a problem. Now, this is back to the familiar two-step equation pattern, which I'm not going to take the time to solve right here. The key for this slide is realizing we can move numbers, we can move x's, we can move things to the left side by getting rid of the 47. We could move things to the right side by getting rid of the 9. We could move the 14x's to the other side by making our 0 on the left. We could move the 6x's to the left by getting a 0 on the right. Any of these things is acceptable. Technically, I could also multiply both sides by 42 or divide both sides by negative 3.7, but these are probably the most useful options. Now, some of you may be wondering why I chose to do this option instead of one of these other twos. There actually is a reason for that. If I had moved the 14x's, when I was done, I would have got 9 equals negative 8x minus 47. Which is fine and is solvable. But in general, we've talked before about the fact we like to have that x on the left-hand side. There has to be a pretty compelling reason for me to move my x off that left-hand side, and in this particular problem, I didn't happen to see one. Also, 6 minus 14 gives me a negative x, which I do not like. By moving the 6x instead, 14 minus 6 gives me a positive 8, and it has the added benefit of keeping the x on the left. Also notice that by moving the variables first, I get this to a form that's very familiar. I could have moved the 9 or the 47 first, but the problem would have looked a little less comfortable, and it's a lot easier to solve if we can keep it in the most comfortable form we can possibly come up with. Now, having said all that, we can do lots and lots of these the same way. I am not going to give the properties this time in writing as we go through. I'm just going to walk through it one at a time. Notice in this problem, I have a minus 12x, which I can get rid of by adding 12x. I have a plus 23 that I can get rid of by subtracting 23. I have a 15x I can get rid of by subtraction. I have a minus 31 I can get rid of by addition. All of those could result in a correct solution to this problem, but we want to do the thing that makes the most sense and makes it easiest to us. If I were to add 12x to both sides, because I like to move my x's first, I would end up with 27x, which is positive, but my x is going to be over here on the right. If I subtract the 15x, I'm going to end up with a negative 27x, but my x is going to be on the left. This is a judgment call and a preference call. Would you rather have negative numbers, or would you rather have the x's on the right-hand side? Because one of those two things is going to happen. In this case, I decided that I would rather have my x's over here on the left than on the right, because it's much more familiar to and comfortable to me that way. For here, I can solve it just like all the other two-step equations. Minus the 23 from both sides. Notice I did not write the plus 0 step this time. I'm starting to eliminate that because I know that's becoming more and more comfortable and it's just less work to do it this way. To get rid of the times negative 27, I'm going to divide it away because negative 27 divided by negative 27 is a 1. Negative 54 divided by negative 27 is a 2. Notice here again, I did not write the times 1. As we get better and better at this, we should be able to skip that step. You can do the check as well. I'm going to put this in here as a reminder. Rewrite the original problem, substitute in the value you said would work, and simplify until the two sides match. When they match, you want to put a check mark there indicating to whoever's looking at your paper that you have verified your solution is correct. Here's another one. I'm going to recommend that you pause the video here, try this one on your own, and then watch the solution. I am going to do the solution quickly when the time comes because it's basically the same type of problem as the previous one. I add my 9x's to both sides, and now it's in that two-step equation form. Add the 94. Notice I didn't write the plus 0 this time. Divide by the negative 7. X equals negative 11. If you did not already do the check, take just a moment and try and check that. Rewrite. Substitute that negative 11 in where the x was. Follow your order of operations to simplify and get the sides equal to each other. If they are not equal to each other, you know you've made a mistake somewhere. Got a couple more for you just in case you need those. I will do these even more quickly. So go ahead and pause the video, try that on your own. Here's the way I chose to do it. Again, it's not the only way to do it, but it certainly is a method that is effective. Over here on the right, you might want to pause the video, try this one on your own. Once again, I'm going to do this one quickly. Notice that I have no problem leaving that as an improper fraction. If you wanted to make it into a mixed number, you certainly could. That would be negative 1 1/10. But in general, decimals are much more difficult to work with, so I'm not going to make it into a decimal. Now, I can make these much, much longer if I want to. In fact, now that you have the basic principle in place, I really can go through and make these as long as I choose. If you were in my class, I could make them as long as the whiteboard goes, and it really shouldn't make a difference. Now, over here on the right, I am going to make a list of recommendations to you. These are not mathematical requirements, but they're things that I found over time make solving these much, much easier. So, for example, I always recommend changing your subtraction to adding the opposite. I will tell you that many of my students resist doing that, and so as a result they continue to make the same exact mistakes over and over again. I can promise you this is one of the most effective things you can do to prevent yourself from making careless errors. Please, 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 of all the steps, do not skip that one. Notice, by the way, that I did put a parentheses around the -5. That's just to separate my minus sign from my plus sign, and that just meant that I had to change my outside parentheses into brackets instead. Actually, I think those are braces. No, those are brackets. Over here on the right, when I changed that minus sign into plus negative, I did make it a plus -1. Remember, I can stick in a 1, a times 1 anytime I want. That is the multiplicative identity. Always do the definition of subtraction first. Always try and get rid of your parentheses using the distributive property. You've got a 3 that can be passed out to both of these. You have a -1 that can be passed out to both of these. Once you've done that, Use your commutative and associative properties to rearrange and regroup. This is often done with mental math. Most students are not going to take the time to rearrange with the commutative property and say 12x plus -2, and then to put parentheses around the numbers. You can if that feels comfortable to you, but just know that most people are not going to do that. Instead, they're going to look at this and realize on the left side of this equal sign, I have 12x's, and then they're going to combine that -2, -15, and -7 to make a -24. Notice over here on the right, the same thing gets done. The -6x goes first. 8, -4, and 2 all get regrouped together and become a 6. Once again, most of my students are going to be skipping this step at this point and jumping straight down to here. Now, I want you to realize that I have not done the property of equality at all yet. In fact, I've dealt with the left side of this equation, everything over here on this side of the equal sign, separately than I've done over here. The reason for that is the property of equality takes a little bit more work, a little more effort, a little more confusing, a little more opportunity for error, so we like to save it until the end. Once I've done all these things, notice my equation takes a very familiar form. It's just like the first several examples that we did. I'm going to add 6 to both sides. I'm going to add 24 to both sides. Leave me with 18x equals 30. Now you know why those two lines were down there. I'm going to divide both sides by 18, and I get x equals 30 over 18, which is 5/3. My goal is always to go from something complicated back to a familiar form, because this much should be almost automatic at this point. Here's another one for you. Take just a minute and try that. I would suggest you pause the video and do this. I'm going to go ahead and continue because I'm going to assume you've already done that. As always, I always get rid of that subtraction first. It does seem to make it a little messier, but I promise you that is going to make this a whole lot easier. Distributive property. I'm going to use my commutative and associative property to rearrange and regroup. Notice I did them both at the same time here. I rearranged and regrouped. Most of my students at this point would be skipping that step and jumping straight to here. Notice the familiar form. I'm going to add 2x to both sides, add 33 to both sides, x equals a 19. If we were trying to be thorough here, and if I had more time, I would go ahead and do a check on that as well. Hopefully that has been helpful to you. It's a pretty thorough way to do these problems. Again, these are not hard and fast mathematical rules. Those of you that are already good at solving equations have probably looked at this and said, yeah, well, I could have done this and I could have done this, and you would have been correct probably to do that. But for a beginner solving equations, this is the way to eliminate the most errors. So I would strongly suggest doing that. Thank you once again for watching. If this has proven useful to you, please take the time to like and subscribe. Also, leave me a comment in the comment section if there's something I can do to make these videos more helpful or more useful for you. Here's a quote from Confucius. It says, "It does not matter how slowly you go as long as you do not stop." Some people are going to pick up on this really, really quickly. Some people are going to need a little bit more practice, but all of you can do this, I promise you. Best of luck. Thanks for watching. Take care.